All right, so evidently I can only record 10 minutes at a time using the free version of Screencastify. So now I know that. All right, I was setting this up and I panicked because it was saying it was going to stop recording, but it's all right, we're back. So our J hat, let's just pretend that didn't happen. J hat, we're going to do the same pattern here with our K and I hat, new I hat column. So 3 times 7, we got 21 minus 40 J hat, and K hat, we got negative 20 minus 35 in the K hat direction. So our vector product of these two, 26 I hat minus 19 J hat minus 55 K hat. So that's how you do cross products. Now let's apply this to torque. Now, on your equation sheet, it lists the equation that torque is the cross product between radius and force. And that is right on your equation sheet, so you don't even need to memorize it. If we have a scenario where we have this super cool wrench and a force is being applied, so we have a force of 4 I hat plus 5 J hat newtons. And the radius of that wrench, I'm going to give some super difficult numbers, 2 I hat plus 3 J hat meters. Now we're going to find a couple things. We're going to take R cross F, and we're going to compare that to F cross with R. And then we're going to find the angle between our vectors. So first, let's take R cross F, make our matrix. So our first letter is going to be the first row, I, J, K, and then our new I hat row. So we have I and J hat values. If there is no value in a dimension, just put 0. So then 4, 5, 0, and repeat our I hat row column, technically. So then when we cross those two, this turns out to be pretty easy. So I hat, that's going to be 0 minus 0 in the I hat direction. J hat, well, hey, look, it's 0 minus 0. K hat, that's going to be our actual value. So 2 times 5 minus 12 K hat. So our resultant vector is negative 2 K hat. That is the torque. Which, if you think about it, if our force is this way, radius this way, perpendicular to both of those, again, is in or out of the page. Okay, now, second part of A, what would we get if we took F crossed R, crossed with? So that means F is going to be on the top row. So then we get still 0 in the I hat direction, still 0 in the J hat direction, and in the K hat direction, we now have 12 minus 10. Okay, so now it's positive 2 K hat. So what this is telling us is that the order of the cross matters. Back when we did dot products, the order didn't matter, but it does matter for cross products. Okay, because if you switch them around, A cross with B is going to be negative if it's reversed. So if whatever the equation is given, okay, you gotta keep it in that order. So when you're given a radius and a force, you got to put radius on that top row. All right, another way we can look at direction, okay, because so we know it's in or out of the page with that K hat, but it's kind of hard to tell which way. So we're going to look at the right hand rule, and then we'll come back to part B. But this isn't just the like curve your fingers and then thumbs up like that. This one's, it's a little more complicated. It involves some like physics gang signs. So what we're going to do, so first you're going to point your index finger along vector A. Okay, so whatever the first one is listed. So if it's a radius, the direction of a radius is always from the center outward. So next, we're going to point your middle finger in the direction of your B vector. Now you may have to rotate your hand depending on how this is set up, but so for this example here, I'm going to try and show you this. So that is the direction of my radius. Now I need to point this finger in the direction of my force vector. So I'm going to need to rotate my hand. So it's going to be just bent down like that. So I basically need to rotate my hand like that. So my force vector is pointed in the right direction. Okay. So now your thumb, you got your thumb over here that's sticking out, will be pointed in the direction of the torque, which for this scenario is into the page. All right, let me see where I went. All right, so then we got to stick them out. So when you stick your thumb out, that is the direction of your vector product. So we knew this product was in the K-hat direction, but we couldn't tell if it was out of the page or into the page. So if the force vector was pointed that way, then we'd have our radius vector and our force vector, and then our torque would be coming up out of the page. Okay, but in this case, it's radius, force, so there's our torque into the page. That was a really good demonstration. Okay, lastly, we want to know the angle between the radius and the force vectors. Now, when we talked about dot products, we said the biggest magnitude is when they're parallel, and this was our equation. For cross products, now we talked about the way to get the most torque out of this is to push on it straight perpendicular, okay, tangent to, our circle here. So our biggest product when R and F are perpendicular, and likewise our greatest torque. So now our equation is going to be magnitude of R times the magnitude of F times the sine of theta. So now we just need to find the magnitude, back up to this problem, of R and F, and then do a little bit of inverse tan or inverse sine action, and we can find the angle between them. And evidently I've recorded for 10 minutes already. Time just flies. So get that product and it'll be on the next video.